Well, hello friends. I'm Shannon Keebler with Empower Consulting, and we're going to investigate comparing fractions. There are several rules for comparing fractions. We first start with number 1. If the denominators are the same, we're going to compare the numerators. So you can see here we're talking about fractions that are part of a whole. In fact, they're part of the same size whole. So you can see our 1 here, their one whole looks like this. And each of these are the same. They're coming from the same size whole. Now, when I compare fractions, I can see that both of these fractions have the same denominator, but they have different numerators. So when I circle 1/3, I can see that it is less than 2/3. 3 is the size of the denominator. This means that it has the same size pieces. Denominators tell us not only the number of pieces in the whole, but they also then tell us the size of the piece. So if it's broken into thirds, we know that the size of the piece is a third. The numerators tell us the number of pieces or the quantity of pieces. So both of these are the same size pieces, but in this one we only have 1 piece versus in this one we have 2 pieces. The pieces are the same size, we just have more of them. So 1/3 is less than 2/3. If the denominators are the same, we compare the numerators. But rule number 2 is if the numerators are the same, we're going to compare the denominators. So if we take our example 1/3 and 1/5, now they have different denominators. Remember, that means the size of the piece has now changed. We're still talking about the same size whole, but in this case, we took the whole and we broke it into 3 pieces. In the bottom case, the purple case, we broke the same size whole into 5 pieces. If I wanted to share my candy bar with some friends, would you rather share a candy bar with 3 people or with 5 people? I'd much rather share with 3 people because that means that my size is a bigger piece. Versus if I share with 5 people, my size of my piece is going to get smaller. This is kind of weird. When we're talking about whole numbers, 3 is obviously smaller than 5. But when we're talking about fractions, we're talking about the size of the piece, how many pieces is the whole cut into. So in this case, we're going to look at the denominator because what we know is the numerator tells us that we still are only talking about 1 of the pieces. So in my candy bar, you only get 1 piece, and in his candy bar, he only gets 1 piece. So we're not going to compare the numerators, we're going to compare the denominators. And thirds are bigger pieces than fifths because fifths have to be cut into more pieces. So in this case, we know that 1/3 is greater than 1/5. The larger the denominator, the smaller the piece. And we're going to say that over and over. The larger the denominator, the smaller the piece. Because it's counter to what we're used to. With whole numbers, the larger the number, the larger the piece. In fractions, it's different. The larger the denominator, the smaller the piece. Rule number 3. If neither the numerator nor the denominator are the same, then we have to find a common denominator. First, we're going to check to see if one denominator is the multiple of another. Next, we're going to find the least common multiple. And finally, if the previous 2 didn't work, if the denominators only have a factor of 1 in common, we're going to multiply the denominators to find a common denominator. Let's try this out to see how it works. Let's compare 7/8 and 3/4. To begin, I'm going to draw a bar model. I have to start with my 8s. So I'm going to take my first bar and I'm going to make it into halves. Then I'll cut my halves into half, and that gives me 4ths. Then I cut my 4ths into half, and I get 8ths. Now I want to shade 7 of them. Next, I'm going to make fourths. I'll cut in half, cut my halves in half. I have fourths. Let's shade 3. As you can see, 7/8 goes further than 3/4. So 7/8 is greater than 3/4. But we have to have other ways to figure it out. Let's use our fraction strips. Now we have 7/8. 1, 2, 3, 4, 5, 6, 7. Let's use 3/4. So now I know that my drawing was accurate. Let's try on the number line. The number line is just a simplified bar model. I have from 0 to 1. I'm going to do 8s. Divide it in half, divide my halves in half, divide my halves in half again. Now I'm going to have from here to here is 1/4. From here to here is 2/4. Eighths. From here to here is 1/8. From here to here is 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Right here is 7/8. 1, 2, 3, 4, 5, 6, 7. If I do fourths, I have 3/4. 1, 2, 3, and now I'm at 3/4. 7/8 is longer than 3/4. Now let's try it doing some math. If I do 7/8 and 3/4, are my numerators the same? No. Are my denominators the same? No. If neither the numerator or the denominator are the same, I'm going to check to see if one is a multiple of the other. Can I count by 8s to get to 4? No. Can I count by 4s to get to 8? Yes. That means the larger of the two gets to be my denominator. 8 is going to be my common denominator. So now I think fourths turn them into 8s. When I had my fourths here, 1, 2, 3, 4, how would I turn them into 8s? I actually divided them in half to turn them into 8s. So that's like multiplying by 2. So 4 times 2 would give me 8, so that means it also would change my numerator. 3 times 2 equals 6. My equivalent fraction is 6/8. Let's find an equivalent fraction over here. 8 times what equals 8? Times 1. So 7 times 1, that equals 7. My fraction stayed the same. Now I can compare. They have the same denominators. If they have the same denominators, I compare the numerators. And 7 is more pieces than 6. So 7/8 is greater than 6/8. Let's try another one. Let's try 1/6 and 3/5. I'm going to first divide my first bar into sixths. So I'm going to do thirds and then split those in half to get sixths. I only need 1. Then I have fifths. I'm going to do 1, 2, 3, 4 lines, which will give me 5 pieces. 1, 2, 3, 4, 5. And I'm going to shade 3. I can easily see that 3/5 is more than 1/6, so 1/6 is less than 3/5. Let's put them on a number line. I have 1/6. I'm going to do thirds. I'm going to cut those in half, and now I have sixths. So I know this is about 1/6. One of the pieces is 1/6. Fifths. 1, 2, 3, 4 gives me 5 pieces. 1, 2, 3, 4, 5. If this is 0 and this is 1. So 1/5, 2/5, 3/5. I can see that 3/5 is further than 1/6. Now let's compare. Are the numerators the same? No. Are the denominators the same? No. That must mean we need to find a common denominator. Are they multiples of each other? No. Let's find the least common multiple. So the least common multiple I could count by fives: 5, 10, 15, 20, 25, 30. I know that 6 also has 30, so 30 is my common denominator. I could also know that if I just multiplied 6 times 5, because one of our rules is if they only have a common factor of 1, then I can multiply the two denominators. Meaning, what equals 5? 1 times 5. What equals 6? 1 times 5, 1 times 6, and 2 times 3. The only thing that's common between these is the 1. That's when I know that I can just multiply 6 times 5 and get my common denominator. 6 times 5 is 30. So now I think 5 times what equals 30 times 6, 3 times 6 equals 18, 6 times 5 equals 30, 1 times 5 equals 5. I now can compare because they have the same denominator. If the denominators are the same, compare the numerators. I have 18 pieces that are the size of 30ths versus 5 of the size of 30ths. 18 30ths is more than 5 30ths. So 1/6 is less than 3/5. Thanks for joining me. Don't forget to like, comment, and share this video so others can enjoy. Thanks for joining me.